Hello everybody. Today we are going to discuss a question that is both simple and complex. The question is, what happens when you touch something, or can you ever truly touch something? Now, before we go into the answers, I want you all to take a moment to think. What happens when you touch something? What's really going on? I'm willing to bet that for many of you, the answer seems very straightforward, maybe even very intuitive. But what I want to do today is I want to take you through 3 levels of thinking of this problem and show you from kind of a high school answer all the way to, say, a graduate school answer, that the answer to this question will actually probe the very depths of physics and force us to ask some very, very fundamental questions about the nature of matter itself and the meaning behind the question. In other words, it's a great problem for a scientist because it's very easy to phrase, but when you unpack it, a lot of complexity and a lot of interesting stuff in there. So first, if you search this question on the internet, which you may well have done before, you will have seen that the majority explanation goes a little like this. As you know, everything is made up of atoms. An atom is a nucleus, which is positive, and then an electron cloud, which is negative. And so if I'm sitting here on this chair right now, or I touch Max, or I give someone a hug, what's happening is that the atoms in my body are then coming up against the atoms in that other object. And what happens is that the 2 negative electron clouds repel each other, which means that they can never overlap, quote unquote, which means there's always a certain distance between the 2 sets of atoms. The implication of this is, of course, is that I sit here on this chair. These are the atoms in my backside, this is the chair, there is a distance between myself and the chair, and therefore, strictly speaking, when I sit down in a chair, I'm actually hovering. I'm hovering in tiny, tiny distance, something like 10 to the minus 7, 10 to the minus 8 meters. When I touch Max, I'm not actually overlapping, our atoms are not overlapping. I actually get close to his atoms, but then the repulsive force stops them from making, quote unquote, contact. So in that sense, the answer to the question, do I ever really touch anything, is no.
Can't touch this. Can't touch this. Can't touch this.
The problem with that answer is it appears like a very neat, logical solution. The issue with it, though, is that it has many flaws. And that's what's going to lead us into some deeper levels of thinking. If you've done high school physics or chemistry, you've probably heard of van der Waals forces. So when I drew that initial diagram, I spoke about Coulomb repulsion between 2 negative electron clouds, but you will know perhaps from your studies that electron clouds are not a fixed concept. If we conceptually draw an atom with a nucleus here and an electron cloud like this, what actually happens is a cloud, not a fixed static representation of electrons. Sometimes this end will be a little bit more negative charged, they'll have a bit more electrons over here than over here, and this one will be comparatively positively charged. What actually happens therefore is that even though all of this is negative, you have fluctuations which are called dipoles. So there might be this might be slightly more positively charged, this might be slightly more negatively charged. If you then have another atom over here, and for the purposes of this thought experiment, this atom's electron cloud is evenly distributed, what will happen is that this will induce a dipole, because there's a positively charged here, comparatively speaking. This part of this atom will be slightly more negatively charged, and this will slightly more positively charged. And these 2 dipoles will create a force of attraction between them. So there are actually 2 forces going on, the van der Waals force that attracts, but then the Coulomb repulsion between the overall electron clouds. The point at which the atoms are held together is really the point at which you would say they were touching, the point at which the forces balance. So the forces may be van der Waals plus gravity plus Coulomb repulsion, something like that. So when we get into this question already, we dig one level deeper, perhaps to the kind of Gaokao answer or the very preliminary university answer. We understand that the interactions between atoms is not as straightforward as simple Coulomb repulsion. But you'll notice the way we're talking about things right now still is very much like classical physics. We're still talking about Coulomb's law and positive and negative charges. But the simple fact is that we know that when we get down to the atomic scale, we actually have to start thinking about quantum mechanics. And that's where the answer to this question gets a lot more interesting and a lot more insightful. So let's go on to the university answer or the graduate school answer. What is the real answer to this question? Well, we need to go all the way back and ask ourselves, does the question even make sense? The one thing we didn't do at the start of this video is to really define what we mean by touch. And if you're an aspiring scientist, or you're interested in the scientific method, or just interested in science, this is one of the most fundamental things you need to do. If you want to do an experiment, if you want to look at a theory, you need to define what exactly do you mean. And what do we mean by touch? Well, touch is a biological concept. All touch is the activation of your nerve endings, sending electrical signals to your brain, which are then processed into a feeling. All you require for that is a force to exert on your hand or parts of your body, and that force can simply be something like Coulomb repulsion. So in that sense, yes, you have touched, because you have activated the nerves that define touch. If you want to talk about this as a physicist, what does touch mean? Well, maybe we've got three separate options. The first option is you can define touch as the nucleuses must overlap. The second is that on a quantum mechanical level, you know that particles are both particles and waves at the same time. That's the principle of wave-particle duality. So maybe the wave functions overlap. The third possibility is that the electrons themselves overlap. Which of those would you define as touch? Well, the first one is not a very sensible definition, because for nucleuses to overlap, well, that's simply nuclear fusion. And nuclear fusion requires a huge amount of energy. It is indeed possible, but only at high energy levels. So I assume we do not mean that by touch. The second option is the overlapping of wave functions. Now, for those of you who haven't studied quantum mechanics, this video is too short to explain exactly what wave-particle duality is, but simply put, it means that an electron or an atom is not just a fixed object in time. You have to look at it in two senses, both as a particle, but also as a probability wave, a wave as well. So it's both a particle and a wave. And you know, if you chucked in two stones on a pond, you'll see ripples coming out. You can think of it a little bit like that. And those waves themselves can overlap. In that sense, the atoms from my body, the wave functions, the waves of my body, can overlap with the waves of that of the chair. And indeed they would. So in that sense, yes, there is touching. On a quantum mechanical level, there is overlapping of the wave functions. However, when we go on to the third possibility of touching, the third definition, potentially, the electrons can't be in the same place at the same time. This is called the Pauli exclusion principle. It's a very fundamental part of quantum mechanics. In a very technical sense, the very technical expression of this law is no two fermions can have the same four quantum numbers. In a very practical sense, that just simply means the electrons can't be at the same place, same time, same energy, same properties. So in that sense, no, the electrons can't overlap and touch. In conclusion, touch is a biological concept. And I think we need to separate that from what's actually going on a physics perspective. On a physics perspective, what is happening is that as atoms come together, atoms can't overlap, electrons can't overlap. That's called the Pauli exclusion principle. If you don't or haven't studied quantum mechanics, you can simply think of this as a repulsive force that presents the atoms and the electrons occupying the same space at the same time. So necessarily what's going to happen is there's going to be a force of repulsion that counteracts the force of attraction. And ultimately what that will mean is that when you're sitting on a chair, when you reach to touch someone else, the atoms in your body will always be held at a specific distance from the atoms in the other object, whether it be the chair, the dog, the person you're trying to hug. In that sense, you are always hovering above something. You're never truly in contact, because there is nothing else that can physically or chemically happen unless you react with your chair. That's the scientific answer. The philosophical answer, can you truly touch something? Well, I'll leave that for you guys to debate in the comments below. Given what I've just told you, do you think that you ever truly touch something? How would you define touching something? Is that a satisfactory answer for you? Has the physics behind it left you feeling more alone in this world or more together with the people around you? I'm interested to hear in everybody else's thoughts. So the philosophical question, can you ever really touch something?